Hello and welcome to today's video. Today's video is for Advanced Geometry, Chapter 11, Section 3, Surface Area of Pyramids and Cones. So just like the previous sections, we have a lot of notes. Just stop it if you need to copy anything down. First, we have a pyramid. It's a polyhedron in which the base can be any polygon and the other faces are triangles that meet in a common vertex. The vertex is the meeting point of the faces of the pyramid. The altitude is the perpendicular segment from the vertex to the plane of the base. So you can see in the picture we have the altitude here. And it's got to be perpendicular to the base. And the height is the length of that altitude. A regular pyramid is a pyramid whose base is a regular polygon and whose lateral faces are congruent isosceles triangles. And something that might be new is called the slant height. So if you take a look at the one that's the second drawing, right here is called the slant height. The slant height is the length of the altitude of a lateral face. So if you take one of the faces of the pyramid and then you find the altitude of that face, then it's called the slant height. And we will need the slant height in order to do surface area. Okay, just like the last section in this book, you can assume that a pyramid is regular unless it's otherwise stated. The lateral area is the sum of the areas of the congruent lateral faces, and the surface area is the lateral area of the pyramid plus the base. So we have the formulas if you want to take a second to copy them down, and then right below that I'm going to show you where they came from. So the lateral area of a regular pyramid is half the product of the perimeter of the base and the slant height. Okay. So if we want to not even include the base, we just want to find the area of those isosceles triangles that go around the pyramid. We take 1/2 the perimeter, just like in the last formulas, except for instead of using height this time, we're going to use slant height. So a couple of things to remember. You need the 1/2 and you need the slant height instead of the actual height, like we use for prisms. And then if we want to find the surface area, instead of being lateral area plus 2 bases for prisms, it's lateral area plus 1 base. One of the things that helps me remember these formulas is to see some of the similarities and differences between the prisms. So what I did is I drew a cube here, so a rectangular prism, a rectangular square prism. And then I also drew a pyramid with a square base. So I just want to look at the lateral areas. So if I take this and suppose I cut off the top and then I opened it up, what I would get is I'd have the base and then I would have the sides would come off and kind of look like this. And they'd be 4 squares. Might not look too much like squares. I'll just make this one a little better. But I'd end up getting 4 squares. And what we talked about before is because, if this is the side and this is a square prism, then what's going to happen is actually I'll call this H. This is our prism formula. The lateral area is going to be 4 of these S's plus the H, and this is just the perimeter, and the lateral area is the perimeter times the height. Now we can kind of do a similar drawing for this one. If you open this one up, what you would end up getting is the base would be the same, but instead of getting squares or rectangles, what you would get is you would end up getting triangles. And if you take a look, the base, you're still going to get this perimeter thing happening. The lateral area is still going to be 4S. But if you take a look at each one of these sides, the area of these is 1/2 S times H. And instead of calling this H, this is actually that slant height thing. It's the altitude of the face of it. And if you rearrange this a little bit, what you end up getting is 1/2. Here's that 4S, which is our perimeter, times the slant height. So a couple things that help me remember. I always think of the pyramid as having faces that are triangles, so I have to remember there's a triangle formula in there, 1/2 base times height. But instead of being 1 base, it's the perimeter. It's all the way around. And then 1/2 of that perimeter times the slant height gives me the lateral area. So here's an example. Find the surface area of the hexagonal pyramid at the left. So my formula is the surface area is the lateral area plus 1 base, and the lateral area is 1/2 the perimeter times the slant height. And if you want to, since the base of this is a hexagon, I can do this is 1/2 the apothem times the perimeter. And that perimeter is the same as the perimeter that I'm going to use for the lateral area. So this is going to be 1/2 the perimeter. Well, it's a hexagon and 6 sides, and they're each 6 inches. The slant height they give me, it's this 9 that's right here. For this one, they also give me the apothem. They've given me a lot in this first one. A lot of times you're going to have to find a lot of this stuff. So they give me that the apothem is 3√3. So right now I'm just doing my 1/2 apothem times perimeter. I'm not even going to worry about the rest of the figure. And the perimeter again is 6 times 6. So for this one, for the first part I get 162. And for the second part, I get 3 times 3 times 6, so 54√3. And I'm going to leave it like that. I'm not going to put it in my calculator. And since it's inches, it'll be inches squared. The next one, the grade, actually I'm going to skip the next one. Remind me in class, I'll do this one if you have any questions on it, but I want to make sure I get all the notes done. Surface area of cones, very much like the pyramids. In fact, I like to use the same formula. So a cone is a polyhedron with a circular base and the sides meet at a point, or you can call it the side meets at a point. The base is a circle. The altitude, again, is perpendicular to the base, to the center of the base. The height is the length of the altitude, and the slant height, again, is this height that doesn't go straight up, it goes along the face. So here are the formulas. I'll read it since it's got cut off a little bit. The lateral area of a right cone is half the product of the circumference of the base and the slant height. So they give you the formula all written out. I like to use lateral area is 1/2 the perimeter times the slant height. It's the exact same formula as what I use for the pyramids, except for this, the perimeter is going to be a circle. And the lateral area, or surface area, is still the lateral area plus a base. So the funnel is in the shape of a cone. How much filter paper do you need to line the cone, or line the funnel? So for this, all I need is the lateral area. And the lateral area is 1/2 the perimeter times the slant height. So the perimeter is a circle, and the diameter is 8, so that's going to be 8 pi. And here I'm going to need to find the slant height. So it's a right triangle. I know this is 4. So this is going to be the square root of 4 squared plus 7.5 squared. So the square root of 16 plus, okay, so I'm going to try to keep this as exact as possible. So I'll make this 15/2 squared. So this is 16 plus 225/4. So make this a common denominator. So this will be 64 plus 225/4. So this will be the square root of 289/4, and it turns out it's a nice perfect square. It is 17 halves. And so now once I have that, I can call that the slant height, so that'll be 17 halves. And then if I multiply this out, so that'll be 4 divided by 2, so this will be 34 pi and centimeters squared. Now one thing to notice, and I do this a lot, this organization thing. So notice here I wrote a formula. You could see me plugging things in. If I had to find anything, I did do that off to the side. I made sure, I've got a little arrow here to show that this is what I'm doing. But it helps when I grade it to be able to see everything. You're welcome to do all your work up here in the formula, but it's kind of nice if you do it off to the side and I can see, oh, here's where you found the slant height, up there's where you plugged it in, and it makes it nice to see. Remember, if I can't, I will try to figure out what you're trying to do, but I'm not going to spend 20 minutes trying to figure out what you're trying to do. So try to make it so it's readable for me and I can follow what you're doing. Don't doodle math in various corners and then all of a sudden you've got an answer and I have no idea where it came from. Okay. And that's it for today's notes. Thank you for watching. Have a great day.